Hello, YouTube. Hi. I've been seeing a lot of things in the rocket science community on some questions, some things that really, I don't know. I've just been seeing things, that aren't good. Not like community wise. Community wise, we're great. Okay. All right. But there are some practices in rocket science that I don't think people are really understanding. And today, in today's video, um, I want to go over some things in rocket science that you should definitely do. So when you first start the game, click on this Discord icon to ask questions. Step 2. A lot of people don't understand really the core mechanics of rocket science. They experiment, they watch videos of, try to find tutorials online of how to play, and that's not where you need to go and look. You see, the places you need to look are real life. How do rockets work in real life? How do we get to Mars in real life? These are how you progress in rocket science, and it's how you learn. It's how you literally educate yourself about space travel, and it increases your predictability and being more interested in space travel. And when you're at a party in the future, you can go and tell your friends, hey, did you know? And because you're going to need to do research in order to play a game like rocket science. So I really want to talk about some fundamental basics today. I want to talk about things that are really good, things that are really, bad, so to speak. Um, and I'm gonna be really like blunt, right? I'm gonna be really blunt, right? So one thing a lot of people do is they come from Kerbal and then they come here. And they think because they have one positive 1.0 TWR that that's enough. It's not enough, actually. It depends on how heavy your aircraft is. That really comes down to it. Your TWR is not calculated. You need to calculate your TWR. The best way to calculate your TWR is by feeling, right? Calculate your TWRs by just shooting a rocket in and checking your altitudes and stuff like that. One thing I see that's really, really bad is improper gimbal. Okay. I'm going to explain it. I've created charts for you guys inside the Discord. In this chart, I'm going to talk about what the proper gimbal in rocket science, like not the game, but in real life and in the game, okay, is your outer rockets should always be non-steerable on whatever rocket butt that you're working on, right? Rocket butt, the butt of the rocket, the bottom of the rocket, right? If you look at the inside of the rocket, right, you have this thing called the center thrust line. And as you change the center thrust line, okay, if my rockets are on the outside and they're changing the center thrust line, okay, that's less efficient than when they're changing the center thrust line from the very middle. That means that you're going to get less fuel to move the rocket if your steering rockets or your gimbal rockets are placed on the inside closer towards your thrust line, right? That's how when you're descending down to Earth or whatever planet you're going down towards, and you want the best performance, people put rockets on the outside. And then they find themselves having to get on the gas and off the gas and on the gas and off the gas and on the gas and off the gas because it's inconsistently doing this as it hits the atmosphere, is wobbling, right? Or it doesn't have as enough of effect of TWR to slow it down, right? So what is TWR? Is your thrust to weight ratio, and it's also going to affect that. These are some things that I really want to talk about, like in the game today. I'm going to go over 3 points to make you a better rocket scientist in the game, and also things that will help you make rockets better in the game. And these are all educational and they're based off real life. I'm going to start off by making a very simple rocket, and I'm going to make a small one. And mind you that my monstrosities that I make are just, they're derpish, right? You know, they're derpish and they're crazy and derpish on purpose, right? Because I like to be creative, right? I like to be creative when I'm building rockets in rocket science, right? Right? I like to do things crazy. But we're going to talk about doing things right. As of now, rocket science doesn't have the parts to do a lot of really awesome things yet, but that will change. The game will evolve, the game will develop, and more efficient rockets will come out. More efficient styles will appear, right? So what we're going to do is we're going to start off with creating a simple satellite, right? And that's what I want to do. So go to your subassembly, create your subassembly, right? You do this however you want. You could do this either in the rocket making it, or you can, make your subassemblies and whatnot. So weight matters in a subassembly, guys. I want you to remember weight is your best friend and it is also your enemy at the same time. Okay? Whenever in rocket science you're creating a weight situation or like a weight issue, right? You have to think about TWR. You got to think about Earth's gravitational pull, and you also need to think about TWR with Earth gravitational pull. Everything above 1 is really good in orbit around Earth to be able to get a line that goes out efficiently, right? It's good. But when you're in sun orbit, right, you need a little less, right? You can get away with 0.1999995, right? But it'll take forever to get there. So we'll just start off simple with just a satellite. So remember your TWR. Remember all of that, right? And actually, no. I'm going to step it up because I think everybody who comes from Kerbal can say, okay, well, I have done that. I have done satellites. They're easy. I've watched a million trillion videos. I've watched a million trillion um things, right? And I know how to get to orbit, right? Well, that's fine. Applied the same knowledge, get to orbit. Good job, you did it. So I'm gonna make a probe that goes into sun orbit, right? So remember, weight is your enemy, right? We're gonna go battery, right? Well, what's the smallest battery we can put on there? Boom. Now, let's go ahead and let's add another square. And let's put a fuel container on here. I'm going to talk about meters a second real quick here. Okay. Right there, 9.0 ms, meaning that it has the most impact to change your meters a second versus something that has less, which is 7.0, meaning that this propellant, right, will propel you at a rate faster than this propellant, right? Theoretically, simplified, right? That's a simple way to say that, right? You have a battery, right? But we need something to obtain solar, right? So we'll just put on solar panels. Now, here we go. You're going to add a rocket. This is a monopropellant rocket, only uses monopropellant. Remember that. It's important. Monopropellant rockets are monopropellant. And the other type of rocket fuel is, not monopropellant. So right here, this is a monopropellant. So usually this guy right here is a monopropellant. That's the case, right? So this right here is monopropellant. I think that's the only monopropellant that we have. Might be wrong. There might be another one in here. So yeah, this is your monopropellant. Monopropellant burns a lot quicker. It's heavier. Right. So you did a good job. But you need a pod, right? You need something to control it. I'm going to talk about what is a reaction wheel. What is it? Well, I'm going to explain it in really layman terms. So reaction wheel, right? I don't like bright things. I like dark themed things. So I'm going to go ahead and, for my eyeballs' sake, right? And yours, right? I'm going to make that dark. And I'm going to say, we're going to go with a white outer shell here. I'm going to create a cylinder here. And I'm going to create another cylinder behind it. Just to showcase this, right? I'm going to take my eraser tool and I'm going to, I like how I'm on my eraser and you're not erasing. Fascinating. Oh, yeah, you are erasing. I'm just, crazy because I made a black background. Okay, now I'm gonna go to the bucket tool. Make this black. Don't roast me for my art skills there. I said black, dude. What is your deal? Paint has gotten like really like bad lately, like with these updates, man, I tell you. It's white still. The heck? What the heck? What the heck? Okay. I'm gonna literally punch somebody. I'm kidding. All right. All right. There we go. Now, please don't do that again. All right. I just need to test to see if this works. We go back here to the brush or the bucket. There, it works now. See why? Why does that not work the first time? Weird. And then I'm gonna just make this black so we can see it. There we go. Back to the demonstration. So here's your reaction wheel. It's a cylinder object, right? That usually is pretty, usually circular, right? Usually circular. And so you have your circular item or your circular object here. And inside of a reaction wheel, there are these magnets, right? We're going to say, we'll say magnets will be gray, okay? You have your magnets, right? And on the outside, there are these red coils, right? Usually, these like red coils on the outside of your reaction wheel. And what happens is it runs off electricity and it attracts the magnet to go from one side to another side, and the rest of the entire reaction wheel is gas. It's air, right? And so when in outer space something has air and something goes to one side to the other, it causes the entire thing to rotate, right? It causes it to rotate. This is important. You need to remember that in the future. So it causes it to rotate, and it's pretty cool without using fuel, right? That's what reaction wheels do, right? So remember that. Remember that in the future. So when we go to I'm going to change this to reaction wheel. When we go into rocket science, you will see you have these cylinders, right? And inside these cylinders, it will say there's a reaction wheel, and they'll tell you the consumption of them, right? And the consumption of them is how much electricity, the electromagnetic in the ring, right? Pulls that ball to one side to rotate it. And it'll tell you how much torque that has in space, right? Or in low atmosphere or wherever, or sorry, high atmosphere, upper atmosphere areas. Important, right? It's going to tell you how much torque you have. So if your item is really big, you need a lot of torque, because the thing will eventually turn, but it'll take forever. It'll take a longer amount of time. But if your item that you're making is smaller, it requires less to turn really fast, to get to prograde, retrograde, and all of that, right? And you're from Kerbal, you know what prograde is. You know what retrograde is. Right. And if you don't know what that is, you can watch many Kerbal tutorials. My biggest like suggestion would be to watch Kerbal. Go play Kerbal. You know, Kerbal is going to help you throughout your endeavor in making rocket science rockets the most advanced rocket game in the rocket game ever. I say that. Right. So anyway, we have our fuel and we have our rocket, right? Cool. We have a 7,710 meters a second with a TWR of 0.7. Now, what does that mean? Right? To get to that menu, to look at what you're looking at there, you're going to go and hover your mouse over that section. Important, can't hover your mouse over this section or this section over the number. Well, your TWR in low Earth orbit is going to be 0.7. Now, in Sun orbit, is that good? Yes. Anything above 0.1 is going to be fine. But when you're trying to go around Earth in Earth's gravitational pull, Kerbal doesn't explain this in a way that's very universal, right? So let me do it for you. Each planet has a TWR resistance that you need to find, right? Especially if you're trying to slow down or trying to increase speed when trying to enter it. Earth's a pretty big planet. So of all the close ones that are around us that are easy to get to, right? So 1.0 TWRs, pretty cool. And Mars, you're going to probably be able to make it, right? You'll probably be able to make it. So this rocket isn't strong enough, doesn't give us the TWR that we need. And so we have to remove it. We're going to upgrade it by putting this down. What did that do? Well, as you can see here, it lowered our TWR by a little bit. Or I'm sorry. It lowered our meters a second because it's using more weight. Remember that. More weight equals more meters a second. Or sorry, less meters a second. Goodness gracious. Right? So that's a problem. We need to figure that out. So we have 6,917. That's fine. But we're still at a TWR that's less than 1. That's not good. So we need to increase that by adding more thrust. How do we do that? Well, a lot of people would say add more thrusters, right? Well, that's the worst thing you could do, is you're adding weight. You want to remove weight. Weight is your enemy, right? So let's do that. We're at 69, right? Let's get rid of that. We're at 98. Let's get rid of that. 1.67. Okay. And that's where it gets kind of sketchy, right? Is you're like, okay, well, I have like no fuel now. That's great. I have only 3,837, right? Yeah, you do. And it's not great. It's not amazing, okay? But it's really efficient. But is it? And the question is it efficient? And the answer is no, it's not efficient. I'm going to tell you why. Because you know the average Earth's TWR of escape is 1.0, right? Around that. 1.15, you know. To get there, that's a pretty good. When you're going above that, you're burning fuel too much. You're accelerating too fast. And when you're accelerating too fast, what can happen is your rocket's not efficient. It's not efficient. It means that this guy right here is too much. It's too much. So how do you lower that? Like, how do you get it lower? Well, you lower the thrust rate, right? We lowered the thrust rate. We need more thrust, right? So we now know is 0.22. So that'd be 2, 4, 6, 8, 10. You would need like 5 of these rockets. But that'd be the most efficient rocket ever if you had 5 of these, right? Because you know you'd be 1.1, right? You'd be at 1.1. That'd be great for Earth. And really efficient for Earth when you're trying to escape Earth, right? So let's just add 5 rockets. Right? So the reason why I said that, well, why didn't we do that from the beginning? Right? Why didn't we do that from the beginning? Well, the reason that we started off with reducing weight is so we understand how to get to efficiency and not go overweight. Because later on, when making a rocket, you're going to need to double these numbers each stage beyond down below. And if your rocket is too big, you can't control it very well, and therefore it's not efficient and it doesn't go as far. So, okay. Well, I want to get a rover over there. It's heavy. Yeah, it is heavy. So you got to be efficient, apply the same logic that I'm using here, and to make the best rocket that you could possibly make, right? So we need to get 5 of these, right? So to get 5 of these without adding a tremendous amount of weight, right? If you look at this guy, this thing is 75 kilograms. This thing is 55 kilograms. We understand that that's going to make a significant problem. And I'm going to show you because we've added weight. That's 4. And we're about to add 1 more, which will be 5. And what is the problem we just ran into? It just took our meters a second down. I said it would be 1.1, and it is 1.1. But it took our meters a second down. And now we have 2,631 meters a second. It's not great. It's really not great at all. So how do we increase our meters a second? We add more fuel, right? So if we add more fuel, we're at 4,000. But then we run into this endless problem of, oh my gosh, now I do not have enough thrust to get there. And you're like, dang, how do we get there? Well, it's simple, really. You've understood. You've went to the beginning. You've added weight. You've deducted weight. You're now able to start to shape to see kind of what different variables are for this spacecraft in the parameters. So what we do is we remove a lot of these and we say these are heavy, right? these are really heavy. So what if I had less of these? What if I had less? So to have less of those, let's go here and grab a 1 to 2 adapter. Flip it upside down and grab it. Now I have 2 rockets, right? I have 2 rockets. Now let's put one there and one there. Well, look at that. We are at 4,000 meters a second. We're at 1.82. Let's just remove one. Let's see what happens. We're at 97. Okay. So we understand now that all we need is just a little bit more. And there it is. 1.06 with a freaking TWR of granditude, amazing efficiency, and our meters a second is around 5,000. That's brilliant. This is incredibly efficient. It has an insane amount of distance that it can travel, and it looks like shit. But it doesn't matter, because when it's in outer space, it'll look cool. All right? It's kind of like that one saying, if a car is driving really fast, it looks cool. And it's true. If you get a Mazda Miata, right, and you put an LS in it and it looks rusty as hell, and you put straight pipes in it, right, and you put it in a parking lot, people will walk by it and say that thing's trash. But then when it's screaming by you at like 150 miles an hour and it's, farting and shooting flames out of its butt, right, it looks really cool, right? So look at that. We have 4,954. Sorry for the crazy analogy, right? So our subassembly's done, right? We've created a probe that can travel almost 5,000 meters a second with a positive TWR to escape Earth. And that means that it's going to be able to pretty much slow down anywhere I want it to go. Well, I want to get to Mars. Well, Mars requires 8,000. Well, I want to get to Saturn. Now, Saturn requires 11,000, right? Well, I want to get to, right? And you start to understand your parameters, start testing, trying to travel to different places. But if you do not build each of your stages correctly and conservatively, you will be making rockets, and your rockets will just be completely different, and you won't know how to get bigger payloads without working on the very top of your rocket. So make sure that that's done. We're going to save this, and I'm going to name it. You hold left alt and left click to name it Explorer. All right. Okay. We're going to go to spacecraft. So we're going to hit new rocket. We're going to grab Explorer first, so the data of the game can realize that this is our command module. We're going to work on the rocket. So on Explorer, we need a decoupling system. Now, there are 2 decoupling modes. I'm sticking onto what's below me, and I'm releasing you above me. Now, that's nice, but I don't prefer it. I feel like the micro decoupler, it shoots the item further off away from the last stage. That's my views. All right. So then, of course, we're going to need a 2. And we're going to need to grab a notched decoupler here, because we're going to have to add a fairing. So there you go. Is that too much? Is that too much? Yeah, that's way too much. This thing doesn't require that much, right? It shouldn't need that much. Well, how do you know? Because you look at the size in which that this is versus this, right? And you also look at this and say, that's a 2.21. 2.21 TWR. Holy crap. That's insane. That's inefficient as crap. So let's make it more efficient. We have 6,000 delta V, by the way. Amazing. So to get there, all right, we would go to our, we'll say our 5 to 2 here. Okay. And then we'll take our 5 to 2 and we'll put our 2 rocket on there. Let's see what that do. Ooh, TWR of 35. So, not great. Rocket's inefficient. Rocket is way too big because you're adding extra weight for no reason. Don't do that. Stupid. Right? Because you're making all the stages below you suffer when you add extra weight for no reason because you say, oh, I have 2.2 TWR. That's great. Oh, yeah, I got like super boost. Right? Fast isn't always great. Now let's look at something like this. 4,000 with a TWR of 5. That's pretty crazy, right? So let's just go ahead and remove that. Let's say, okay, well, again, we're way too big. So let's try this. 2,000 with a TWR of 10. That's good. Because now what we can do is grab our adapter and go from here to here and grab our 2. We're at 2. We're at 2. That's good. That's good. That means that our rocket is really condensed. It's really small. All right. We're at 1.77, so it's up there touching 2, right? We don't want it to be touching 2. So what we want to do is give it some more meters a second. Is that enough? It is. Look at that. We have 4,283 meters a second, and this thing is tiny. You see that? That's how you use your brain when making rockets. It's tiny, but it has so much to give. We're at 1.09 with 4,000 meters a second. Right. Pretty good. Tiny's good because that means everything below us isn't going to, what did I say earlier? Is not going to suffer. It's not going to suffer. So now what we're going to do is we need to go one stage bigger. So that's a little bigger, right? This thing is just, well, actually, let's do some math. We have 5.15 ton. We have 8.0 ms. 0.52 ton. 0.15 ton. So this is just a little, like literally 0.2 something ton bigger, right? That's fine. It's just a 0.2 ton bigger, right? That's pretty good. Sweet. Let's go ahead and let's make this even more efficient, right? Let's make it even more efficient. So what we're going to do now is we're going to go ahead and remove an unnecessary stage. And what I'm going to do is put an adapter on here. And I'm gonna put it in the middle. Hit my R key and rotate this so I can actually get this right. I'm gonna move this over just a little bit. We're gonna remove more weight. Right, we're removing even more weight because I have an idea. So 1.09, and this thing has even more TWR now. This has a little bit more TWR. We're condensing this down even smaller, which is great. Same dealio, okay? We're gonna take this guy, place it here. We're gonna grab a basket. Come on. Yeah. Grab a basket. I'm gonna move this with this guy. Remember to always decouple, right? Remember always to decouple and then fire. Do not fire, then decouple, or you're going to have a bad day. Okay? Right. So now, we're going to go to our adapters. Let's just place this here for now. I'm going to actually delete this item because it's a bug where it just works better. All right. Now, I might go ahead and use another piece, or I might condense it even more, depending on what happens next, right? So what happened? This thing is shooting off, and it has 1,306. Right. So if we were to go here to save and launch the vehicle, we're not really going to launch the vehicle. It's going to fix the bug. Okay, good. It fixed the bug. I'll go back to assembly shop. Alright, boom. So we click on new rocket double time, and now we're back to editing. So now, what we're going to do is figure out, okay, how do I win? So now what I'm going to do is I'm going to place a simple rocket down and see where we're at base-wise. We're at 2,000 with a TWR of 0.1. So we now kind of get an idea of what we're going to need. So if I go to my rocket stage here, there's a TWR of 3,000. But I need to be similar, right? I need to be similar. So, but I need more TWR to push all of the things above it, right? So if we need more TWR to push all the things above it, we want this stage to be around 5,000. Right? I know what you're saying. This says 1,386, and it does. It's a glitch. And it will not say that once the rocket is done and we launch it one time. The variables will kick in. But you saw what it said it was, and that is what it is, right? So it's still 4,000, or did I stage it wrong? No? Okay, no, I staged it right. Okay. So now what I'm going to do is add a stage here. What do I want? I want there to be just a little bit more in this stage than before, right? So here's where I can go a little bigger and go a little bigger because it's time to go a little bigger, right? It's time to go a little bigger. So let's go a little bigger and let's get this thing working. 3,000, right? It's pretty good, but I need this thing to have around 5,000. Oh no, I'm at 3. And this is at 600. See, that's not making any sense at all. Did I put this basket on backwards? I did. Hold on. How much does that basket weigh? Oh, no. No, now it's reading right. Okay. There we go. I fixed it. There we go. Now, see that it glitches out again. Weird. I'm gonna have to fix that. Alright, so yeah, I'm gonna have to report that and get that asserted pretty quickly. Alright, so this is a beta build, by the way. 3,627. I know that that's correct, right? So we're at 3, 4. So 4, 5, 6, 7, 8. Right? We need to get to 10. Right? We need to get to 10. So we have a TWR of 1.75. We can't do any more than that. Maybe we can. Maybe we can. Now this gives me a TWR of 1.77. It's going to give me 0.77 extra, which might be what I need. So what I'm going to do is grab a radial version of this, and we're going to just start off with 2 because you want to add weight slowly. And I want to see what that gives me. That gives me a 7,000. Wow, that's definitely enough. Let me get rid of this and put that there. 4,000 plus 4,000 is 8,000. So again, we're going to need more fuel. So we'll do that now. This time we're going to go 3. We're going to go up 1. We don't want to add too much weight. This is just for testing purposes. I'll clean it up in a second, right? So put that there. Stage that to stage 2. Why is there 2 decouplers in here? That's probably bad. This one. Okay, that's why it was tripping out. Okay, now I fixed it. Alright. That's why it was tripping out. Actually, there was no bug. There was no bug. It was me not seeing the staging correctly. Right, so we're at 4,785, 6, 7, 8, 9. Right? We need 10,000 to escape Earth. All right, so does that mean with TWR is getting down to 1.10? So remember that. So we're going to go 4 this time. Okay. And then we're going to add a rocket. 5,000. There it goes. With 97. Which is good. Because we can add simply oh, you really? That's not enough? I was thinking that would have been enough. How many of these will it take? 1. 102. 107. Right, so that'll be 107. Now let's clean it up. Let's add in some of these. And it should be 1.1. Oh, it's still 107, so that didn't break the weight. Okay, good. I want a little bit more. Get it just a tiny bit more. Oh, I can't do that. Okay. 5,000 plus 4,000 is 9. 5, 4, 5, 6, 7, 8, 9. Sweet. This guy shoots for 9. Sweet. So, we're at 9,000. Remember that? Our goal is to hit 10,000. Right? So that means that, okay, well, how much do we need to get out of Earth, right? To get into space, you need 4,000, okay? We need a little bit left over, right? We need a little bit left over. We need about like 2,000 left over to get into space, right? Right. So what we're going to do now is we're going to go to our basket and we're going to make our stage to go to Earth, right? Right. So we're going to grab our big fuel tank and I'm going to add 4. Okay. And we're going to add 1, 2. And we're only going to add 2 right now because it's important to only add the smallest amount that you need. All right. So our center thrust will be a turning rocket. And our outer thrust will be a rocket that is chill. That's 2,000 with 2.23, right? Woohoo. We've hit a dilemma. So how do we fix that? Respectfully. We add twice the amount, right? We need around 3,000 or 4,000 in this stage. We can add that same amount by simply doing this to keep things condensed, right? And put the center thrust there is 3,000. Let's place that there. 3,000. And our TWR, of course, is 32. So we have to get that to above 1. And some change. And that'll do it. That's 3,000. 3. This guy's like 4. Oh, we need 4,000 to get out, right? So we're going to need more. So we're going to go ahead and grab another layer. And that should be more than enough. Oh, I messed up. 4,400. So we just need a little bit more. $4,900. We're gonna need a little bit more. I'm gonna get to around 5,000. $4,800. 4,900. TWR of 82. Hold on. Okay. So we've realized now that this is quite expensive and it's getting kind of tall and getting kind of heavy. So what we're going to do is, instead of adding all of these crazy fuel configurations, we're trying to shrink this rocket and make it very small. So we're going to add a bigger fuel tank. Let's start off with this and let's see where we're at. 2,000. 2,800. 3,000. 3,600. 4,000. 4,315. Good. So now, again, we need to shrink this and make it even smaller. You see how we're working to shrink, right? 3,000. 4,000. Okay, you've got the number. So now what we need to do is add in some radial rockets. We'll start off with 2. Center thrust line TWRs of 71, that's fine. Right, start off with 2, we're at 3,000. Now we're going to add our 2 fuel lines here, or 2 fuel tanks here, to add some more. 3,790. Okay, we're into the 4 range. Okay, so Let's go with 3. Okay, we're going with 3. Okay, and 4,082. Those are not touching. Okay, they're not. 4,700. And we're going to add in our turn rockets. Gets us to 93. $4,600. Remember that. We want to get to 5,000. Now to do that, we need to remove weight. And all of a sudden, it goes up. $3,000. With a TWR of 1.21, 3,916. 4,000 is as much as we need to get out of the atmosphere. We need to add in another layer. So to do that, we just go from 3 to 4. We're not trying to make taller. We're trying to condense, right? Trying to condense. Make sure you're always condensing your rockets. Here. $4,147. And that is the correct configuration. 4,200. 4,244. 4,300. 385. 4,500. 4,700. 4,800. 4,000. 5,000. 5,085. With a TWR of 1.43. That is how you condense your rockets. Remember that. That is how you condense your rockets to make sure that your TWR is good. Okay? Now, this is important. Make sure that these are not touching. If they are touching, they will blow up. Now, we're going to need to add in gyro stabilizers. Now, this is 5,085. It's a little tall. I want to condense it down even more. Right? So let's just take this away. What's this times 3? 0.52 tons times 3 is 150. Right? Yeah, around that. 150 to maybe 160. Right? 1.12 ton. I add that down. And let's just see what it looks like when we put a couple of these down. $5,031 with TWR is increased. We were able to shave off the weight. We've increased the TWR. Pretty good. I'm going to keep things symmetrical here. Whatnot. Okay, now we need our gyro stabilizers. We took off about 16 millimeters, which this rocket's pretty big, so, you know, we took off quite a lot of space, right, from that rocket. So now what we're going to do is grab our gas decoupler, or sorry, our gyro stabilizers. so we can steer this rocket. And this is at 49999, which is okay because we are still okay. We have plenty. We have freaking plenty. But our TWR didn't take an impact. Aerodynamics. I want the cheapest weight cones in the game. These are way lighter than those guys, and that's 49994. And what I might do is manually add some fuel. Nine seven. These are fuel containers, by the way. 98. Nine 999. Let's just 5,000. Just like that. So we're at 5,000 with a 1.47 TWR. It's not pretty, okay? But it's efficient, right? It's an efficient rocket. All right? And now the next step is to now go to our aerodynamics and place our fairing. So this guy goes to space. And there you go. You have your rocket. Very condensed, very small. Very, very good. So, I'm going to put my decoupler here. 4,987. I calculated for that. Amazing rocket. 4,987, 5,000, 4,000, 9,000, 10,000, plus 4,000. Let's launch. All right, here we go. We are going to begin our launch and our gravity turn. I'm going to always kind of touch this edge of the ball here. Right here. And I'm going to wait till I reach about 10,000 meters. I'm at 7. Very efficient. And this is where Kerbal comes in, and what I'm going to talk about is fine-tuning your rocket to be better, right? 4,000 meters. $5,000 meters. $9,000 meters. Since what we break through 10, I'm gonna go for 30 now. it's gonna tip. Might be able to save it. All right, so we're very bottom heavy. So I need to realize that. And we win. I'm gonna go ahead and relaunch, actually. So our rocket doesn't like moving at 30. That's a little violent. So we're gonna try to get to 30 earlier, I think. That's what we're gonna do. What I'm gonna do is get to 10,000. I'm gonna be a little bit more aggressive here. I'm letting the energy flow through my rocket right now. So my meters a second right now is not strong enough to punch through the atmosphere, and I'm going to talk about that in a second. So far, it's passing. I think she'll make it to 30. Really gotta get to 30. Okay, we're on 30. And now we just let it sit here, and we need these meters a second to go up. Okay, that's good. Actually, the rocket's fine. So we're just gonna stick at 30. Sure it doesn't leave that 30 line. Every time the rocket moves, the energies are no longer going through the rocket, therefore creating the the problem, with acceleration. It'll be depleted. We're gonna leave around 3,000. That's really good. We need to get to at least 60,000 to do a nice fairing. Decouple here. Okay, and now we're going to set this to prograde. And now we've hit orbit. We're at 100,000. very efficient, right? We talk about efficiency, right? Earlier. There's a reason. Once we find an Apple Abscess that we like, we go ahead and cut the engine. We're going to fast forward time. Go about right there, and we're going to regain our engine cut, our engine burn here, so we can get to that target time. And there we go. We've achieved orbit around Earth. That's great. We're going 8,000 meters a second. Good. So now we're going 8,000 meters a second. It's time to do our stage to get us to prograde. Ooh, we have an issue. We have a problem. I'm going to talk about that problem here in a second. We do not have stabilization, and we're going to need to fix that. So, the rocket does what we want it to do. Now, we need to create a stabilization problem. We also had a decoupling issue, so we need to add a stage, and we need to give it some time to decouple. So stage 2 will be our decoupling stage. Right. So next is trying to solve the problem with this. So we're going to grab our gyro stabilizer. And we're going to place it there. It's 4,000 still with a TWR of 10.5. It's very good. Restage the rocket now. 5 rockets on the bottom. Base, explode. 5 rocket. Double. And decouple. 4,000. Okay. And bearing. Stage 2 fairing. Okay. I'm going to see if that's enough stabilization now for the rocket to stay kind of in its, you know, and that's the reason. If you add stabilizers, right, early, you're adding weight. And when you add weight early, you're essentially destroying your, you're destroying your rocket's weight, right? So again, it's about adding things only when you need them. Alright, I've reached 10,000 meters. I'm gonna head over to 30 now. As fast as the rocket will let me. To stick on 30 here. I'm not going to move from 30. All right, now we're building up meters a second. And we're climbing to about 60,000, right? While building up meters a second. As the rocket continuously stays in the angle that it needs to, energy passes through the rocket, increasing your meters a second. The second I move the rocket, the energy is removed from the rocket, depleting your meters a second. Now, you're not going to lose speed. It's going to go to 0 meters a second, but it's going to cause you to not effectively use your fuel, right? We're at 3,500. Right, we're at 80,000 meters. And our fairing is kind of stuck. All right. Now I'm going to set it to prograde here. And we're just going to send it. We're just going to try to get to our target. Leaving Earth. That's really what we're going to do. We're going to really leave Earth. 4,000 and we're climbing. I'm about to hit 5,000. Our TWR will increase as our fuel depletes, meaning weight is released, right? If weight's released, our TWR increases. $5,000. The further we get away from Earth, the easier it is to maneuver on the planet. Especially if we're going to Mars, is around 400 kilometers from the planet, right? So you kind of want to get out there. 5,500. We're zooming right now. It is 6,000 miles an hour. As you can see, that 300 is just spiking right now. The hundreds are spiking a second, and that's what you want. You're going to increase that velocity, 6,000. $7,000. $8,000. All right, and we're 8,600. $8,700. $8,800. $9,000. Once we reach that 10,000 miles an hour is when Earth will let us leave. At 9,400. 9,500. 9,600. 9,700. 9,800. 9,900. You're at 10,000 miles an hour. Now we're getting ready to leave. There's a bug. I'm going to go ahead and get us back on course here. All right, and we have escape. And we have a pretty great escape, actually. Now, what we're going to do is we are going to do a stage separation. There we go. We are stage separation. We are then going to grab this node here. Add a maneuver plan here. We're going to set Mars as the target. And I'm going to attempt to try to go to it. Hmm. It's gonna be kind of difficult. Almost. I didn't launch at the right date. But I still might be able to do it. Hmm. Yeah, I'm not gonna make it. I have a Earth gravity assist that takes me out there though. I want to try that really quick. All right. So we have a problem again with gyro stabilizers. So that's why we're spinning. All right. So that was kind of a Earth basis kind of demonstration to how to play this game more efficiently, more right. Of course, the launch date for Mars is, you know, uh, yeah, it's not. It's July 17th. Yeah, it's July 17th. Sorry, I had to kick on my brain out of that mess. This beta I'm playing right now is not good. And there are some things I need to write down. he changed the reaction wheels. They're spinning like crazy. So I'm gonna have to talk to him about that. But yeah, that's just kind of an example how to build a rocket correctly. And you know, take that for what it was to help you in your games. Peace out.